Hello students, today we'll start with continuity of a function. Now when does a function is continuous? A function f of x is said to be continuous at a point x is equal to a of its domain. The point x is equal to a, the point x is equal to a must lie in the domain of the function f of x. If the point does not lie in the domain of f of x, then we do not check the continuity of the function at that point. So the point should lie in the domain of f of x. So a function is said to be continuous at a point x is equal to a of its domain if and only if, IFF stands for if and only if, limit x tend to a f of x is equal to f of a. That is, a function is continuous at x is equal to a if and only if limit x tend to a negative f of x, limit x tend to a negative f of x. A negative means we subtracted infinitesimally small value from a, means the x lies on the left of a. So x tend to a negative f of x, this makes the left hand limit, is equal to limit x tend to a positive. Now we added something very infinitesimally small to a, means x lies on the right of a. So this is called right hand limit, is equal to the value of the function. That is, at x is equal to a, left hand limit should equal to right hand limit is equal to the value of the function at x is equal to a. So you can see, to understand, to solve the questions on continuity of a function, it is very much important that you should able to solve the limit. So before proceeding with the continuity, I will just brief you about the limits, the methods we use to solve the limits. Like, first method is method of factorization. Method of factorization. What do we do in this method? If limit x tend to a, limit x tend to a, f of x upon g of x is of the form 0 upon 0, is of the form 0 upon 0, and fx and gx are polynomial functions. Polynomial functions. Then x minus a is the factor of both numerator and denominator. So make factors, comma, cancel the common factor, then put the value of x. So that's how we use the method of factorization. This is first method to solve limits. So this is the first method to solve limits. Then we have second method, that says method of rationalization. Method of rationalization. Now what is this method? If numerator or denominator contains irrational factors, irrational terms, then rationalize and then cancel the common factor and apply limits. So this is your second method. Third method, you have limits at infinity. So in method of rationalization, what we do? Say numerator or denominator both contain, or any one of them contains irrational factors. rationalize those irrational factors, cancel the common factor, then apply the limits. Third is limits at infinity for like limit x tend to infinity f of x. Then put x is equal to 1 upon y, so that as x tend to infinity, y tend to 0. Or for limit x tend to minus infinity, f of x, put x is equal to minus 1 upon y, so that as x tend to minus infinity, y tend to 0. So this is third method. This method is rarely used in continuity because we rarely find continuity at infinity. Rather, we do not find continuity at infinity. So that's why this method is not used in finding the continuity of a function. Then we have formulae of limits. Very first formula, limit x tend to a, x raised to power n minus a raised to power n upon x minus a. It is n a raised to power n minus 1. Second, limit x tend to 0, sin x upon x. This is 1. Now in this case, you need to remember that the angle of sin x should be in radians, and that should equal to denominator, and that denominator should tend to 0. Only then this limit comes out to be 1. Similarly, limit x tend to 0, tan x upon x is also equal to 1. Number 4. Now be careful. Limit x tend to 0, cos x upon x is not equal to 1. Fine. Then limit x tend to 0, sin inverse x upon x is also 1. Limit x tend to 0, tan inverse x upon x is equal to 1. Number 6, limit x tend to 0, 1 minus x, 1 plus x whole raised to power 1 upon x is equal to e. Number 7, limit x tend to 0, log of 1 plus x upon x is 1. Number 8, limit x tend to 0, it is a raised to power x minus 1 upon x is equal to log a to the base e. Number 9, limit x tend to 0, e raised to power x minus 1 upon x is equal to 1. Say this is the same formula. You can substitute a with e, so you will have log e to the base e. Log e to the base e is 1. So that's why limit x tend to 0, e raised to power x minus 1 upon x is equal to 1. In all these formulae, what you need to understand or what you need to take care is the angle of tan x should equal to denominator, and that should tend to 0. Similarly, here x should equal to denominator, and that should tend to 0. Similarly, 1 plus x whole raised to power 1 upon x. Here x and here 1 upon x, there should be equal, only then it could be equal to e. Here x and denominator should equal, and that should tend to 0, only then equal to 1. The power of a and denominator are equal, should be equal, and that should tend to 0, only then it will be equal to log a to the base e. Similarly, the power of e raised to power e and denominator are equal, and that should tend to 0. And one more thing, if limit x tend to a, fx raised to power g of x is of the form 1 raised to power infinity, then limit x tend to a, f of x raised to power g of x is equal to e raised to power limit x tend to a, f of x minus 1 into g of x. So this can be used for a number of times. So this is about the brief about of the limits, how the limits can be used. Now, I haven't taken any question on the limits because our primary objective is not to solve the limits. Our primary objective is to find the continuity of a function. So let's try a few questions on continuity and see how it works out. The very first question is, a function f of x is defined as f of x is equal to x square minus x minus 6 upon x minus 3 when x is not equal to 3 and 5 when x is equal to 3. Examine the continuity of the function. Examine the continuity of the function at x is equal to 3. Examine the continuity of the function at x is equal to 3. Now you can see function is defined as f of x is equal to x square minus x minus 6 upon x minus 3 when x is not equal to 3 and f of x is equal to 5 when x is equal to 3. So first of all we calculate the limit at x is equal to 3. So limit x tend to 3 f of x. Now tend to 3 means x is not equal to 3. If x is not equal to 3, f of x is x square minus x minus 6 upon x minus 3. Now both are polynomial functions. If we substitute x is equal to 3, 3 square 9, 9 minus 3 6, 6 minus 6 0, 3 minus 3 0, 0 upon 0 बन रहा है. Then x minus 3 must be the factor of both numerator and denominator. So we can split the middle term. Limit x tend to 3, x square minus 3x plus 2x minus 6 upon x minus 3. Solve this. This is limit x tend to 3, x minus 3 into x plus 2 upon x minus 3. Cancel the common factor. This is limit x tend to 3, x plus 2 is equal to 3 plus 2 is equal to 5. And what about f of 3? When x is equal to 3, the value of function is 5. So clearly limit x tend to 3, f of x is equal to f of 3. So that satisfies the definition that limit x tend to f of x is equal to f of a. This implies f of x is continuous at x is equal to 3. So see, it's very easy. First of all we find the limit at x is equal to 3. For finding the limit, since it is a polynomial function, so we make the factors, cancel the common factor, put the value of x, find the limit, then find the value of function at x is equal to 3. Both are equal, therefore function is continuous at x is equal to 3. Clear? Another question. If f of x is equal to, if f of x is equal to sine 3x upon x when x is not equal to 0 and 1 when x is equal to 0. Find whether f of x is continuous at x is equal to 0. Now first of all you need to find the limit. So limit x tend to 0, f of x. Tend to 0 means x is not equal to 0. When x is not equal to 0, the value of function is limit x tend to 0. It is sine 3x upon x. Now to evaluate this limit, the formula is applicable when the angle is equal to the denominator. So to make them equal, what we do is limit x tend to 0 sine 3x multiply and divide by 3. Now this angle and denominator are equal. As x tends to 0, 3 into 0 is 0, so 3x also tends to 0. So this limit comes out to be 1. So this is 3. And what about f of 0? When x is equal to 0, function is 1. Clearly, limit x tend to 0, f of x is not equal to f of 0. So this implies function f of x is discontinuous at x is equal to 0. So if the function is not continuous, that is called discontinuous function. A function which is not continuous at a point, that is called function is discontinuous at x is equal to 0. Discontinuous means function is not continuous. Also, if the limit exists but it is not equal to the value of the function, then it is called removable discontinuity. Removable discontinuity. This type of discontinuity can be removed by redefining the value of function at x is equal to 0. If we define at x is equal to 0, the value of function comes out to be 3. Then they become equal and function becomes continuous. So that kind of discontinuity where limit exists but it is not equal to the value of function, that is called removable discontinuity or discontinuity of first kind or discontinuity of first kind. And if limit does not exist, then we say it is irremovable discontinuity or discontinuity of second kind. We'll take up in some other example. So right now check it out. Limit exists but it is not equal to the value of function. So it is not continuous, means it is discontinuous, and this type of discontinuity is called removable discontinuity. Another question. Let f of x is equal to 1 minus cos x upon x square when x is not equal to 0 and 1 when x is equal to 0. Show that f of x is discontinuous at x is equal to 0. Discontinuous at x is equal to 0. Solution. So first of all, let's calculate the limits. Limit x tend to 0 f of x, that is limit x tend to 0 1 minus cos x upon x square. Now 1 minus cos 2a, we have a formula that says 1 minus cos 2a is 2 sine square a. Using that formula, this is limit x tend to 0 2 sine square x by 2 upon x square. So we can write this as limit x tend to 0 2 times sine x by 2 upon x the whole square. Now to make this angle same, what we will do is limit x tend to 0 2 times sine x by 2. We need an angle x by 2 into 1 by 2 the whole square. Now this angle and denominator are equal, and as x tends to 0, x by 2 also tends to 0. So this comes out to be, this limit comes out to be 1. So you have 2 into 1 into 1 by 2 the whole square. This is 2 into 1 by 4, which is 1 by 2. And what about f of 0? When x is equal to 0, the value of function is 1. The value of function is 1. This implies limit x tend to 0, f of x is not equal to f of 0. This implies f of x is discontinuity. Discontinuous at x is equal to 0. See, Easy? Another question. Test the continuity of the following. Test the continuity of the following function. Continuity of the following function at origin. F of x is equal to mod x upon x when x is not equal to 0 and 1 when x is equal to 0, or you can say 0 when x is equal to 0. So here we have a function mod x upon x. Now in the beginning I have told you that left hand limit should equal to right hand limit. Now where do we find left hand limit and right hand limit separately? Left hand limit and right hand limit are to be evaluated separately only when number one, modulus function is involved. Modulus function is involved. Second, greatest integer function is involved. Greatest integer function is involved, or f of 1 upon x, or fourth, f of x is defined as g of x for x greater than a, greater than equal to a, h of x for x less than a. So for greater than a function is different and for less than a function is different. Over there we calculate left and right hand limit separately, or function of 1 upon x is involved, then also we calculate left hand limit and right hand limit separately. Greatest integer function is involved and modulus function is involved. So in these four cases we calculate left hand limit and right hand limit separately, otherwise there is no need to calculate them separately. So there are only four cases where we calculate left hand limit and right hand limit, because modulus function is involved. F of x is defined as mod x upon x. So here we calculate left hand limit and right hand limit separately. So for left hand limit, limit x tend to 0 negative mod x upon x. Now you know the definition of mod x. What is mod x? Mod x is equal to x when x is greater than equal to 0 minus x when x is less than 0. So 0 negative means you subtracted something from 0. So when something is subtracted from 0, then x will be less than 0. If x is less than 0, then mod x is equal to minus x. Using that, it will be minus x upon x. This cancels. So you are left with minus 1. What about right hand limit? This is limit x tend to 0 positive mod x upon x. 0 plus something. So you added something to 0. So when you add something to 0, the value of x will be greater than 0. When x is greater than 0, then mod x will be equal to x. So limit x tend to 0 positive x upon x. This comes out to be 1. Left hand limit is not equal to right hand limit, implies limit x tend to 0 f of x does not exist. Now when limit does not exist means function is discontinuous, implies f of x is discontinuous at x is equal to 0. So function is discontinuous. If limit does not exist, then the function is discontinuous at that point. And this kind of discontinuity is called irremovable discontinuity or discontinuity of second kind. This is discontinuity of second kind because limit does not exist. So let's take a few more questions. Discuss the continuity of the following functions. Of the following functions at the indicated points. The indicated points. Discuss the continuity of the following functions at the indicated points. The first question you have, f of x is equal to x minus a into sine of 1 upon x minus a when x is not equal to a and 0 when x is equal to a. We need to check the continuity at x is equal to a. Now, limit x tend to a f of x is limit x tend to a x minus a sine of 1 upon x minus a. Now sine 1 upon x minus a, that comes out to be, if you substitute x is equal to a, what you will get is x, a minus a is 0, 1 upon 0 is infinity. Now the angle comes out to be infinity. Angle is not infinity. Angle over here comes out to be infinity. So at infinity, we know the maximum value of sine is 1 and minimum value of sine is minus 1. Means the sine, this value sine of 1 upon x minus a will lie between somewhere between minus 1 and 1. So it will keep oscillating between minus 1 and 1. Whereas this x minus a comes out to be 0. So you can say a minus a into an oscillating number between minus 1 and 1. So this is a finite value and this is 0. 0 multiplied by anything is 0. So limit x tend to f of x is equal to 0. And what about f of a? We are defined when x is equal to f of x is equal to 0. This implies limit x tend to a f of x is equal to f of a, implies f of x is continuous at x is equal to a. Now there is a general mistake in this question. This is the right way of doing the question. And what a general mistake people do, that I tell you also. What students generally do, they write it like this: limit x tend to a sine of 1 upon x minus a upon 1 upon x minus a. It's okay. Mathematically this is correct. No harm in it. Now what students do, the angle and denominator are equal, so they jump on to the conclusion that this limit comes out to be 1. But there were two conditions. Angle should equal to denominator and that angle should tend to 0. But this angle, when x tends to a, tends to infinity instead of 0. So this is not equal to 1 because 1 upon x minus a does not tend to 0. So that's why generally students make this mistake that sine of 1 upon x minus a upon 1 upon x minus a, angle और denominator equal किया और इसको 1 लिख देते हैं. But that cannot be equal to 1 because when x tends to a, 1 upon x minus a does not tend to 0. The angle should also tend to 0, only then this limit comes out to be 1. So be careful about this mistake. Another question. F of x is equal to e raised to power x minus 1 upon log of 1 plus 2x if x is not equal to 0, and 7 if x is equal to 0 at x is equal to 0. Now let's talk about the limit at x is equal to 0. Limit x tend to 0 f of x is limit x tend to 0 e raised to power x minus 1 upon log of 1 plus 2x. Now we have two limits. One says limit x tend to 0 e raised to power x minus 1 upon x is equal to 1. Other is limit x tend to 0 log of 1 plus x upon x is also equal to 1. These are two standard limits. In both the limits, here power should equal to denominator and that should tend to 0, only then it is equal to 1. Second, the value of x over here in denominator should be equal and that should tend to 0, only then it equals to 1. So to make it a standard form, what we'll do is divide numerator and denominator by x, e raised to power x minus 1 upon x whole divided by log of 1 plus 2x upon x. Now here power and denominator are equal, but here the value of over here is 2x. So make it 2x, multiply and divide by 2. So this is 1, this is also 1. So 1 upon 1 into 2 is equal to 1 upon 2. And what about f of 0? The value of function at x is equal to 0. It is given as 7, implies limit x tend to 0. Limit x tend to 0 f of x is not equal to f of 0, implies f of x is discontinuous at x is equal to 0. Since limit exists but it is not equal to f of 0, so this kind of continuity is removable discontinuity or discontinuity of first kind. Now we shall move on to another question. Discuss the continuity of the following function at the indicated points. F of x is equal to 2 times mod x plus x square upon x when x is not equal to 0 and 0 when x is equal to 0 at x is equal to 0. Now since modulus function is involved, mod x is there, so we will calculate left hand and right hand limits separately. So what about left hand limit? It is limit x tend to 0 negative f of x is equal to limit x tend to 0 negative 2 times mod x plus x square upon x. Now we know the definition of mod x. As I told you earlier, it is x when x is greater than equal to 0 minus x when x is less than 0. So 0 negative, 0 minus something. So something has been subtracted from 0. Means x is less than 0 when x is less than 0. Limit x tend to 0 negative when x is less than 0. It is minus x. So minus 2x plus x square upon x. This is limit x tend to 0 negative minus 2 plus x upon 1. Take x common and divide numerator and denominator by x. So this is minus 2 plus 0 is equal to minus 2. Left hand limit comes out to be minus 2. Right hand limit, limit x tend to 0 positive f of x. This is limit x tend to 0 positive 2 times mod x plus x square upon x. This is limit x tend to 0 positive. Now when x is greater than 0, 0 plus something, x is greater than 0, mod x is equal to x. So 2x plus x square upon x. This is limit x tend to 0 positive 2 plus x is equal to 2 plus 0 is equal to 2. Clearly left hand limit is not equal to right hand limit. So limit x tend to 0 f of x does not exist. If left hand limit is not equal to right hand limit, then limit does not exist, means function is discontinuous at x is equal to 0. And this kind of discontinuity is called irremovable discontinuity or discontinuity of second kind. Another question. Show that f of x is equal to 1 plus x square if 0 is less than equal to x is less than equal to 1, and 2 minus x if x is greater than 1 is discontinuous at x is equal to 1. Now you can see for x greater than 1 function is defined differently, and for x less than 1 function is defined differently. So when this is the case that for x less than a and greater than a function is defined differently, we choose to find left hand limit and right hand limit separately. So over here left hand limit, this is limit x tend to 1 negative f of x. 1 negative. Now one thing must be clear to the students, that 1 negative means 1 minus something. We subtracted a very small value from 1, infinitesimally small value from 1. 1 negative does not mean 1 minus something, does not mean minus 1. So many students make a mistake that instead of writing it as 1 minus something, 1 minus, you can write 1 minus 0. Okay? Instead of writing 1 negative, they put the value of x is equal to minus 1, which is wrong. It is 1 minus something. So when x is less than 1, 1 negative, when you subtract something from 1, the value of x comes out to be less than 1. So when x is less than 1, the function is 1 plus x square. It is 1 plus 1 square is equal to 2. And what about right hand limit? This is limit x tend to 1 positive f of x. Again 1 positive means 1 plus something. 1 plus something means we have added something to 1. So when something to 1 is added, x will come out to be greater than 1. When x is greater than 1, the value of function is 2 minus x. It is 2 minus 1, it is 1. So left hand limit is not equal to right hand limit, implies limit x tend to 1 f of x does not exist. Now if limit does not exist, implies f of x is discontinuous at x is equal to 1. So where limit does not exist, that kind of discontinuity is called discontinuity of second kind or irremovable discontinuity. Let's take up another question. Find the value of k. Find the value of k if the function f of x is equal to sine 5x upon 3x if x is not equal to 0, k if x is equal to 0 is continuous at x is equal to 0. Now first of all let's evaluate the limit. Limit x tend to 0 f of x. This is limit x tend to 0 sine 5x upon 3x. Now this limit exists if the angle is equal to denominator. So to make them equal, what we'll do is limit x tend to 0 sine 5x upon 5x into 5 upon 3. Multiply and divide by 5. So this comes out to be 1 into 5 by 3 is equal to 5 by 3. The value of limit is 5 upon 3. Now because f of x is continuous at x is equal to 0, this implies limit x tend to 0 f of x is equal to f of 0 implies 5 upon 3 is equal to f of 0. When x is equal to 0, value of x is, value of function is k. So k is equal to 5 upon 3. That's how we calculate unknown in this kind of questions. Let's take another question, one more question, then we'll sum up this lecture. That says, find the value of a. Find the value of a so that the function f of x is equal to ax plus 5 if x is less than equal to 2, x minus 1 when x is greater than 2 is continuous at x is equal to 2. Now just look at the function. For x less than 2 we have a different function, and for x greater than 2 we have a different function. So that kind of function we calculate left hand limit and right hand limit separately. So left hand limit x tend to 2 minus something. 2 negative means 2 minus something f of x. 2 minus something means we have subtracted something from 2. If we subtract something from 2, the x will come out to be less than 2. When x is less than 2, the value of function is ax plus 5. Limit x tend to 2 negative. It will be ax plus 5. So this is limit x tend to 2 negative. So put the value of x, a into 2 plus 5. That is 2a plus 5. And right hand limit, that is limit x tend to 2 positive. F of x, 2 positive means 2 plus something. When x 2 plus something, then x will be greater than 2. When x is greater than 2, function is x minus 1. So 2 positive x minus 1, it is 2 minus 1 is equal to 1. And what about f of 2? When x is equal to 2, it is a into 2 plus 5, which is again 2a plus 5. So because f of x is continuous at x is equal to 2, therefore left hand limit is equal to right hand limit is equal to value of function at x is equal to 2. Implies 2a plus 5 should equal to 1, implies 2a is equal to minus 4, implies a is equal to minus 2. So that's how the value of unknown is evaluated. So again, to be very clear, where we calculate left hand limit and right hand limit separately, left hand limit and right hand limits are to be evaluated separately. 4 cases are there. Number 1, modulus function is involved. Number 2, greatest integer function is involved. Number 3, function of 1 upon x is involved. Number 4, function is defined separately for less than a and greater than a. So these are the 4 points which you need to keep in mind while evaluating limits and solve the questions accordingly. So try few of the questions. Tomorrow we will return with few more questions. Thank you.